download videos. All right. So let's get into section R3. Everybody loves long division. From elementary school, did long division with numbers. We're in college. We're going to do long division with polynomials. Is what we're going to be doing. So long division with polynomials. If you'll trust me and follow the steps here, it's not bad. It looks like it's just rocket science, but it's not. It just looks bad. Okay. So we're going to take two polynomials. So let's say we had x cubed plus 6x squared minus 8x plus 10. And we're going to divide that polynomial by x plus 3. We're going to use long division to divide it right now. We'll learn synthetic division in just a minute out of this. Okay, so written like a fraction, that just means division. Okay, so we're going to do long division here. And I'm going to put the x plus 3 on the outside. And then it's not a square root symbol. It's the old long division symbol from ages ago. Okay, so we got x to the third plus 6x squared minus 8x and then plus 10. All right, so the key here is to look here. Kind of like that map in the mall where it says you are here. Okay, so you're going to start by looking at the x in the front of what you're dividing by. That could be an x squared, depending on what you're dividing by here. This one, it's just a plain x. What you want to do is look at that. Don't worry about the plus 3 right now. It doesn't really do anything until we get something done. All right, so we want to look at the x and say, what times that x would get me x to the third power? X squared. So that's what's going to go up top. Okay. The next thing to do is distribute x squared to this polynomial that's out front. So that would be x squared times x, which is x to the third, and then x squared times plus 3 would be plus 3x squared. Okay. Distribute x squared to x plus 3. Subtract. Old long division, when you were in elementary school, you subtracted. I always put parentheses around what I got when I multiplied there. And then I put a subtraction symbol outside. So what should happen here, every time when you do that, x cubed minus x cubed, what happens to them? They cancel out. If they don't cancel out, you didn't do it right. Okay? So that's canceling out. And then we have 6x squared minus 3x squared. It's a minus sign out here every time. 6 minus 3 would be 3x squared. And then I'm going to bring down the minus 8x. Okay? Then I look here again. What times this x would get me 3x squared? 3x. I need a 3 and I need another x. So I'm going to put a 3x up there on the top. So it's a plus 3x. It's plus because that's a positive 3x down there, or 3x squared down there in the bottom. Okay? So I need a positive 3x up here to match it. Then I'm going to distribute again. 3x times x plus 3. 3x times x is 3x squared. 3x times plus 3 is plus 9x. Parentheses, subtract. Okay? The 9x. All right, so where did 3x squared come from? It comes from 3 times x. 3x times x. The 9x, 3x times this plus 3 is, right? So you're distributing, whatever we put up here, we have to distribute to everything that's here. Okay. Every time. Okay? Then we're going to parentheses and subtract. The x squareds go away. That's what they should do. If they don't, we didn't do it right. Then we have negative 8x minus 9x. Negative 17x. I'm going to bring down the plus 10. Then I look at that place again. I look here again at the x. What times x gets me negative 17x? Negative 17. So that's what goes up top. What do I do with that negative 17 now? Distribute it to the x plus 3. So negative 17x, negative 51, parentheses, subtract. And then negative 17 minus negative 17 cancels out. That's good. That means we did it right. 10 minus negative 51. 61. That is my remainder. The way we're going to write our remainder in this polynomial division, a little bit different than what you did with numbers. When you were a kid, you divided something, if you divided 13 divided by 3, you got 4, subtract, remainder 1. That's how you wrote it a lot of times. Y'all remember writing anything like that? It's been a long time since you did that, but that's what it was. Now, what that really means is it's 4 1/3. If you think about 12 over or 13 over 3, it's 4 1/3 as a mixed number. So what we're going to do is we're going to write this as the polynomial x squared plus 3x minus 17. That's from the top. And then we're going to put a plus sign and then do 61 over x plus 3. Always a plus sign. Remainder on top. What I divided by on the bottom.
So whatever's on the outside of the bottom
is always going to go there. The only time this won't be here is if the remainder is 0. And then there's just not a remainder to write there. So your answer would be that. So this is what we divided. Our quotient, this is our answer. This is our remainder over what do we divide it by. Always going to be that way.
Where did you get that 51 from a while ago?
17 times 3.
Okay.
That's where that's from. Distributing that minus 17. Okay. So it looks like it's just, crazy big stuff, but it's really not that bad. Let's look at another one. I'm going to go ahead and write it in the long division setup just so we save a little bit of time and to rewrite the problem. Understand that would have probably been written in fraction form with 2m minus 1 on the bottom. So we have 4m to the third minus 8m squared plus 5m plus 6. Okay. Where do we look? The 2m on the outside. Notice what order are both of our polynomials in? Descending order. They better be. If they're not, it's going to make it really, really hard. So make sure they're in descending order. Most of them will be already. You won't have to really worry about that too much, okay? But just check for that. So if you run into one you're having trouble with, check the descending order first. It may be that. So we look at that 2m. 2m times what gets me 4m to the third? 2m squared. Notice I'm putting that above the m squared. I like to column, make columns there and think, okay, these are where the m squareds go. That's not necessary, but it sure does make my life make sense when things are organized like that. You would think everything I own would be organized. It is not. That's why I do it with math. It's easier to do with the 4-year-old or 5-year-old and a 2-year-old. It ain't happening. All right. So now what do we do with that 2m squared? Okay. So that's going to give us 4m to the third. That's what we intended to happen. And then 2m squared times negative 1 would be negative 2m squared. Parentheses, subtract. always. Parentheses, subtract. The m cubes go away, and we have -8 minus -2. -6m squared, bring down the plus 5m. Where do we look? 2m times -3m. Job. And what do we do with that? Distribute. So -6m squared. What goes next? Plus 3m minus 3m. Plus, because it's negative, negative. And then parentheses, subtract. Yeah. Cancels out. The m squareds are gone now. 5 minus 3. Bring down the plus 6. Now what? Plus 1. 2m minus 1, parentheses, subtract. Distributive properties, all that we're doing there. 1 times 2m is 2m. 1 times -1 is -1. Subtract. The m's go away. What's my remainder? 7. So when we write our answer, 2m squared minus 3m plus 1 plus what? Good job. Not bad at all. Not bad at all. Okay. Questions about that one? Not bad. It's a steady process. It may not be, multiplication table is kind of easy, but it's pretty easy. Let's do one that's not as easy, because that's how it goes. All right, so x squared minus 4 divided into 3x to the third minus 2x squared minus 150. Okay. What do we notice about this one? Doesn't have a regular x on the outside. Doesn't have a regular x on the inside either. That's a problem. If it's not there, what is it? It's 0. So what we want to do is put a placeholder there. If you don't put it there, you can still work the problem, but it gets a little tough because of the organization of it. Because then you don't have a term to subtract or add to. So I always rewrite these with a placeholder in the outside, and then I'm going to put a placeholder for whatever is missing. It just so happens that these are the same piece missing, but one of them could be missing the x squared and the other one missing the x, x plain x. They just happen to be the same one on this one. But if it's not there, make sure you put a 0x in the place of it. And now we look at the x squared and say, what times x squared gets to be 3x to the third? 3x. Well, that goes way on that end. So that's 3x squared or x cubed, and then 0x squared and -12x. Parentheses, subtract. So this one starts out looking pretty rough, but it's going to end pretty quickly. So subtract, these go away. It'll be -2x squared, and then positive 12x. Bring down the minus 150. What times x squared gets me -2x squared? -2. Distribute it across. That was easier because I don't have to do the letters. Just the -2. That's -2x, 0. +8. Be careful on signs on that. Then simplify. 12 minus 0 is 12x. -150 minus 8 would be -158. That's my remainder. How do I know that's my remainder? And I don't need to keep going. Right. The x squared is too large to go into it. So that's how I know I'm done. Okay. So my remainder is 12x minus 158. So I have 3x minus 2 plus 12x minus 158 over x squared minus 4. And I just rewrote that using the shorter version of the divisor, what I divided by, instead of x squared plus 0x minus 4. There's long division with polynomials. But it doesn't get any more difficult than that. You may have, a longer problem, but the process is steadily that over and over and over. Okay, so it doesn't get any more difficult. Just may require a little bit longer duration. Page 30, 89 through 94. So that we've getting the partial sections here is what we're dealing with. All right. Again.